In this video, I'm going to be showing you how to graph polynomials using the leading coefficient test, intermediate value theorem, and the zeros of the function. This shows you versions of what a polynomial function looks like and what a polynomial function does not look like. So for example, on the left, it is a smooth, curved graph which represents polynomial functions. On the left, the top is not a polynomial because it actually has a sharp turn. This is actually an absolute value function. It is not a polynomial function. The second one also is not a polynomial function because it's discontinuous, means that there is a break in the graph. And so that will not give you a polynomial function. Steps to graphing a polynomial. The first thing you're going to do is you're going to look at the function's degree. In a previous video, we discussed the highest degree of a function. Next, you're going to look at the leading coefficient, whether it's negative or positive. And then you're going to look for any x-intercepts or y-intercepts. Basically, where does the graph cross, the x-axis or the y-axis? So, parent functions. The different types of parent functions of a polynomial would be, again, based off of the highest degree. So, x cubed, x to the fifth, x to the seventh, all have very similar graphs. If you notice, it goes down in one direction, it goes up in the other direction. Or if you read from left to right, it constantly is moving up. If the highest degree is even, for example, x squared, x to the fourth, x to the sixth, then on the left-hand side and the right-hand side of the graph, both go in the same direction. So these both go up in these directions. Again, if it's an odd number, the left side is going to go in one direction, the right-hand side is going to go in the opposite direction. But if it's an even degree, the highest degree is even, then the left-hand side and the right-hand side are both going to go in the same direction. So for example, in behavior, we're not looking about what's happening close to the origin where the graphs cross each other at 0, 0. We're looking out of what's happening when x is very large in the positive and x is very large in the negative. So this is an odd degree because the left-hand side is going in one direction and the right-hand side is going in the other direction. So this is an odd degree, meaning this is going to be some type of x cubed or x to the fifth or x to the seventh, x to the ninth. Now, if the leading coefficient is positive, for example, if you had y equals 2x to the fifth, or you had y equals just x to the seventh, or y equals 100x to the third. If the leading coefficient is positive, then it is going to have the general graph of this. So as x is going very, very big, meaning as x is going towards infinity, as it's getting very, very big, then the y values are also going to infinity. So as x is getting very big, y is also getting very big. Now, as x is going to all of the negative values, so as we're looking more left, as x is approaching negative infinity, y is going down, which means y is also approaching negative infinity as well. If the leading coefficient is negative, so for example, if we had y equals a negative x to the fifth or y equals a negative 10x to the third, if the leading coefficient is negative, then the opposite is going to happen. As x is approaching as x is getting very, very big in the positive direction, this is where the graph goes down, where all the y values are going in the negative direction. So as x gets very, very big, y is actually going in the negative infinity direction because it's going down. And as x is getting to become negative numbers, as x goes left, the y value actually gets really, really big. So as x gets really, really small, y actually gets really, really big. So this is what they would call the left hand and right hand behavior. Left hand meaning as x approaches negative infinity. The right-hand behavior is as x is approaching infinity. So left hand is basically when x is approaching negative infinity because you're going to the left. And right-hand behavior is wanting to know as x is approaching positive infinity, what is the y value doing? So if it is an even degree, meaning it has y equals x squared, y equals 100x to the 6th, any type of even degree, if the leading coefficient is positive, then both y values are getting really big. They're going up. So as x is approaching infinity, y is approaching infinity. So as x approaches infinity, y also approaches infinity. As x is approaching negative infinity, as it goes left, y is still doing the same thing as the other side. As x approaches negative infinity, y still approaches infinity. No matter what, going left or right, y is still going up. If the leading coefficient is negative, for example, y equals a negative x to the 10th power, or y equals negative 5x squared, what's happening as x is approaching infinity, y is going down. As x approaches negative infinity, y is still going down. So as x approaches infinity, y is approaching a negative infinity. And then as x approaches negative infinity, going left, y is still approaching negative infinity. So if it's an even degree, the y values are going to do the same on both sides. They're either both going to go up or they're both going to go down. So for example, we want to sketch this graph. Now, we do not know necessarily where it crosses the x-axis, but we can kind of have an idea of what the graph's going to look like. For example, the leading coefficient is 4. So, So for example, the end behavior of this, we do not know necessarily where this graph is going to cross the x-axis or anything, but we can at least use the end behavior to do a general sketch of this graph. So for example, the highest degree is a 4, which is even. Okay, so we know that it's either going to be something like this or it's going to be something like this. We don't know which, we just know that since it's an even degree, then it's both going to go up or both going to go down. So the next thing we look at is the leading coefficient. Okay, leading coefficient is negative in this case. So therefore, it's going to look like this. So we don't know what's going on in here, but we do know that the result is going to be going down. The only other thing at the moment that we can do is we can find the y-intercept. If we plug in 0 for x, we'll get 0 plus 0 minus 0 plus 50. So we do know that it is going to cross at 0, 50. We don't really know what's going to happen in between there, so it could go like this. We don't really know, but the only thing we do know is that far away as x approaches infinity, as x approaches negative infinity, we know that the graph is going to end up going down. So we know it's going to look at least something like this. We don't really know what's happening in here, but we do know that way out here, it is going to get, the y values will both go to negative infinity. Now, the zeros of a function are where the x value, or where it crosses the x-axis, or where the x values are 0. So in this case, the zeros of this function happen here, happen here, happen here, and happen here. So in this case, there are 4 zeros of this function. We also know turning points. So for example, the turning point would be any type, what you could say would be like a hump. It goes from a negative slope to a positive slope, or it goes from a positive slope down to a negative slope, or here it goes negative, like it's decreasing and then it's increasing. So in this case, There are 3 turning points. Now, there is actually a theory that basically says that how many ever turning points there are, then the highest degree of that polynomial is going to be at least one more than that. Meaning, since there are 3 turning points, that means this function is going to be either in x to the 4th, in x to the 5th, in x to the 6th, in x to the 7th, in x to the 8th. It can be continue on. It just can't be an x squared. So therefore, whatever the turning points are, you have to add at least 1. Now, we also know, if you notice, that both the left-hand side and the right-hand side are both pointing up, which means it's an even function. That means it is going to be an x to the 4th, an x to the 6th, or an x to the 8th, or an x to the 10th. We just know that it has to be an even number for its highest degree. So, finding zeros. The real zero, if x minus a is a factor of a polynomial, then x equal a is a solution, and then a comma 0 is an x-intercept. So for example, if we were to find all the zeros of this function, well, the first thing we know is that we have a common factor. In a previous video, we discussed how to factor a polynomial. There is an x value in every one of these terms. So if I pull out an x, we're looking for 0, so we're set equal to 0. If I pull out an x, I'll get x squared minus x minus 2. I can factor this into 2 parentheses. I will get x minus 2 and x plus 1. Now, since everything is equal to 0, we can now set each of these terms to 0. So we know that x equals 0, we know that x minus 2 equals 0, and we know that x plus 1 equals 0. So we'll get x equals 0, we get x equals 2 if you were to solve for 0, and we'll get x equals negative 1. So I know that at 0 it crosses the x-axis, I know that x at 2 it crosses, and I know at negative 1 it crosses. Now, next thing I know, if you look at the leading, not the leading coefficient, if you look at the highest degree, it is a 3. An x cubed is going to take the form of this. Remember, any odd highest degree means that on one side it's going to go up and on the other side it's going to go down. The leading coefficient is positive, which means it's going to take on this form. So we know that it's going to go to infinity on this side and it's going to go to negative infinity on this side. And it has to cross at these 3 points. So I can sketch the graph. It must go up, down, and back up from this point. We don't know how high up it goes at this turning point. We also don't know how low it goes, but we do know that at least it's going to continue to go down, and on this side it's going to go up on the right-hand side, and it crosses at these 3 points. And that is how you're able to sketch a graph knowing the zeros. The multiplicity is when a 0 is repeated. If the multiplicity of odd, then the graph will cross the x-axis. If the multiplicity is even, the graph will actually bounce off. So for example, if I want to find the zeros of this function, I first can see that I can factor out an x squared. If I factor out an x squared, I'm left with x squared minus 1. 1 because I had to have a placeholder. Now, I can actually set, well, I can, hang on. I now can factor x squared minus 1 becomes x plus 1 times x minus 1. Now I can set each of these terms equal to 0. So x squared equals 0, x plus 1 equals 0, and x minus 1 equals 0. So we know that x equals, so when you take the square root of x squared, we will get plus or minus 0, which we don't say, we just say that it happens 0. We also know that x equals negative 1 and x equals a positive 1. However, at this point, this is actually called a multiplicity because this is an x squared. You could say x times x plus 1 times x minus 1 equals 0. So you could say that x equals 0, x also equals 0, and then x equals -1 and +1. So there is a multiplicity that happens at 0, because 0 is basically repeated twice. So we know that at 0, I'm going to put like a little m because it's a multiplicity. And then at -1, it crosses, and at +1, it crosses. Now, the highest degree is a 4, which means it is even. The leading coefficient is positive, which means it's going to look something like this. The y values go up on the left-hand side and the right-hand side. So we know it goes up on that side, goes up on that side. We also know that it's going to cross at -1 and at 1, but it's going to bounce at 0 again because there is a multiplicity. So it's going to look something like this. It's going to go through at -1, it's going to come back and bounce at 0, and then come back, except it's supposed to go back through. Go back through at 1. We don't know how far down these turning points go, but we do know that it has to come back up to bounce at 0, and then go back up. So let's sketch a graph. Remember, we're going to talk about end behavior, zeros, and multiplicity. So first, you're looking for, is there anything in common to be able to find the zeros? Well, there's an x cubed in common. If we pull out an x cubed, we'll get 3x minus 4. So we'll get x cubed equals 0, which means x equals 0 with a multiplicity of 3. Why 3? Because there are 3 x's. And then we have 3x minus 4 equals 0, which means x is going to equal 4/3. If you were to solve for 0, you would add 4 and then divide by 3. So I know that at 4/3, which is about right there, and at 0, we know that it's going to cross the x-axis. We also know that the end behavior, first, we know that it's even. So if we look at the end behavior, we know that it is an even function, and we also know that the leading coefficient is positive. So we know that it's going to end going up on both sides. But we also know that it crosses. So we know that at 0, there's a multiplicity of 3, so it's going to kind of cross at 0. It does not bounce because that is not an even multiplicity. And then it's going to go back through at 4/3. And it's going to go back up from there. And so that is how we can sketch this graph based off of the end behavior and its zeros. Now there's an intermediate value theorem that states that there exists a 0 in between two values of x. For example, if I plug in -2 into this function, I'm just going to choose -2. I'll get -2 cubed plus -2 squared plus 1, which will give me -8 plus 4 plus 1, which is -3. So I know that at -2, the coordinate point's -3. I also know that if I plug in -1 into here, I will get -1 cubed plus -1 squared plus 1, which will give me -1 plus 1 plus 1, which will give me 1. So if I plug in -1, I will get the point 1. So here's what the intermediate value theorem basically states. At -2, I have a negative value. But at -1, it becomes positive. If you notice, it goes from a negative to a positive. That means there must be a 0 in between -3 and 1. I can't include negative, I'm sorry. There must be a 0 between -2 and -1. And the reason is because it goes from a negative to a positive, which means for them to connect, it had to cross the x-axis at some point, which means there is a 0 that lies in between these two x values. So let's review. When sketching a graph, you're going to look at the end behavior, which means look at the highest degree and the leading coefficient. Then you're going to factor the polynomial to find any zeros and look for any multiplicities. So this is already factored for us. So we know that x minus 2 we can set equal to 0, and x plus 3 we can set equal to 0. So we know that x equals 2, but there's a multiplicity of 2. That gives us the multiplicity. We also know that x plus 3 there is a 0, which means that x equals negative 3 there is a 0. So we know that at 2 there's a multiplicity, and at x equals negative 3 there's also a multiplicity. The multiplicity of 5. Now, we are only worried about even multiplicities. So, because only when the multiplicity is an even number is it going to bounce. So, first, in behavior, highest degree. Well, we have an x squared here. We have an x to the 5th here. So 2 plus 5 is 7. So we know that the parent function is an x to the 7th. We also know that it's positive. And x to the 7th means it is going to be an odd, which means it's going to go up on the right-hand side and it's going to go down on the left-hand side. Now, we know that at 2, it is going to bounce. So I'm going to go ahead and just put an asterisk because at this point, it is going to bounce because it's a multiplicity of an even number. At negative 3, it's going to go through because it's odd. So we know that this graph is going to look something like this. It's going to go up, but it has to bounce here, which means it's going to have to go down and curve back up at that point. The only other thing that you could probably sketch is if you plug in 0, you can figure out where it's going to cross the cross the y-axis. But sketching purposes, look for the end behavior, find any zeros, and then look for any multiplicities.